All right, hey Algebra 2. Here is the first video for section 2.3. We're going to be graphing equations of lines. Okay, so in the previous section we covered slope and rate of change. So now we're going to apply that a little bit in terms of now let's try to graph these lines using the slope. Okay, here's our first definition. Specifically, we're going to be using the slope-intercept form to graph these lines. Okay, so when the graph of a line has the equation y equals mx plus b, the slope of the line is m, so our m is our slope, and our y-intercept is b. Hopefully that's review, and this is known as the slope-intercept form of the equation of the line. Okay, so go ahead and pause the video and jot that down if you haven't already done so. Let's go ahead and use that information to graph a few lines. So here's our first example. Example 1, I forgot to write the 1 when I was creating this outline, but it is example 1. Graph the following equations that are in slope-intercept form. So just take a look at these examples first and notice that they're all in slope-intercept form. So for our first one, we have our slope is, remember if there's no coefficient in front of the x, then it's implied to be 1. And our y-intercept, since there is none, there's technically a plus 0 here. So our b is 0. For example B, or sorry, part B of example 1, we have our m is 2, our b is 3. For part C, we have our m is negative 3, and again, our b is 0. And then for D, our m is negative 2/3, and our y-intercept b is negative 1. Okay, just so we're kind of on the same page, and that way we know how to identify the parts. When we think about part A, y equals x, that's a special linear function. You'll hear it be called lots of different things in your mathematical career. For example, in this case, when we're talking about lines, it's the parent function. So this is the parent function for linear equations. Okay? We'll have parent functions for all the other functions we talk about in this class, like quadratic functions, exponential functions, the list goes on, okay? So for this one, let's just graph that really quick. We have a good amount of space, so let's make it nice and big. Okay, and then I can just do a few tick marks. We don't need too many for our first one. We'll need a few more for the other ones. Okay, so y equals x. How can we use our slope and our y-intercept to graph these equations? Well, we start with our we start with our y-intercept, our b. My b is 0, so that means that my line is going to hit the y-axis at 0, which in this case is the origin. So we can put a dot there. That's our starting point. And then we're going to use our slope to find the rest of the line. Okay? So slope, remember, that's rise over run. Whenever you're given a whole number slope, that's always technically divided by 1. So our rise is 1, and our run is 1. We're going to go up 1, over 1, up 1, over 1, etc. So up 1, over 1, here's my next dot. From there, up 1, over 1, here's my next dot. Up 1, over 1, you get the idea. Okay, and then you can also do it in the opposite direction by reversing both of the directions, right? So if I went up 1 to the right one, now I want to go down 1 to the left one to follow the line. Down 1 to the left one. Down 1 to the left one. Okay? And then I'm going to use my Keynes ruler to connect the dots. It might not be pretty, but it's handwritten. It's as pretty as it's going to get. Sorry for my hand. There we go. That's our line, graphed using the slope-intercept form. Let's do the rest of these. Here's our next one. Make it 1 bigger. just to give myself more room. Oh. Sorry, that's a little hideous. You figure I could follow a straight line, but I guess I can't do that. Okay, so let me make some tick marks first. If your graph is already done, you could probably fast forward this part, right? That's the beauty of having these videos recorded. If you're one step ahead of me, do not hesitate to fast forward. Boop, boop. Okay, so y-intercept is 3. That means it's going to intersect our y-axis. I should be labeling these. It's going to intersect our y-axis at 3, positive 3. 1, 2, 3. And now here's where we use our slope. We're going to go look at our slope. It's 2 over 1. Rises 2, runs 1. Rise 2, so go up 2 over 1. Up 2 over 1. And we can do that in the opposite direction, reversing both directions. Instead of going up 2 over to the right 1, down 2 to the left 1, down 2 to the left 1, etc. Now we use our ruler to make a nice line. As nice as it can be, because we are not perfect people. Perfect in my mind. Okay, so then now you probably have the hang of this. Go ahead and graph these 2 lines. Actually, never mind. Let me go ahead and do one of these with you, since it's a negative slope. Let's do C, and then I'll let you do part D. Okay, if you already have your coordinate plane ready to go, fast forward. Do, 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 do. Okay, so same idea. Our y-intercept is 0, so that's our starting value. But now we have a negative slope, so it kind of changes a little bit. Okay, so that means that my rise is down 3, but my run is still to the right, because remember, I want to read my graphs from left to right. If this is going to be a negative slope, I want to make sure that it stays going down as I go from left to right. Okay, if I reverse both of those directions, then I actually just end up with another positive line. Okay, so starting from our y-intercept, down 3 to the right 1, down 3 to the right 1. Okay, now to get the other side, I reverse those directions. I go up 3 to the left 1, up 3 to the left 1. Okay, and then again, connect the dots. Beautiful, gorgeous line. Okay, now go ahead and do part D. Notice that we're going to go down 2 to the right 3, down 2 to the right 3. When you reverse directions, up 2 to the left 3, up 2 to the left 3. Okay, give that a shot. I'll see you in the next video.